All right, welcome back. What we're going to do is we're going to go through a little tutorial on how to perform operation of functions, and we're also state the domain. All right, so here's some examples. We're going to take and we're going to perform operations of given these two different functions. We have f of x, which is negative 3x to the 1/3 and 4x to the 1/2, and g of x, which is 5x to the 1/3 and plus 4x to the 1/2 power. And what we're going to do is we're going to add these values together. So we have several different examples I'm going to go through. The first one we're going to do is we're going to add these two values together. So we're going to take g of x. So here's our function. And we're going to add it to f of x. So essentially what we're going to do is we're simply adding the outputs. So replacing this underneath there. Okay, so we're going to take 5, all right, x to the 1/3 plus 4x to the 1/2. And we're going to add that to f of x. Now f of x you can see is that one right there. So we're going to take f of x, which is going to equal negative 3 x to the 1/3 plus 4 x to the 1/2 power. All right. From here, we're going to combine our values because when we're adding and subtracting, we're going to only be able to add like radicals. So this is x to the 1/3, which means it's the cube root the cube root of x. We're going to add that. So we have 5 of these minus 3 of those. So we're going to have, I'm going to change the color here. We're going to have then 2x to the 1/3 power. And then right here, we notice that we have this and this is the same. All right, so we're going to add 4 plus 4, which is going to be 8 of those. So 8x to the 1/2 power. Now, that is actually our final answer because we can't combine any more values. And so that is what our answer is going to be. Now, to figure out the domain, our domain are what values we can plug into this function. Now, our domain starts with our original functions. So if f of x and g of x, in both these, the domain of this, since we have the square root, all right, so x to the 1/2 is actually the square root. So if we have negative 3, it's going to be the cube root of x, and it's going to be plus 4x, or the square root of x, right here. This side is going to be 5x to the cube root of x, and then we're going to have plus 4, and it's going to be the square root of x right there. Now, the domain is what can we plug in here? Well, inside of cube root, I can plug any x value into a cube root function. However, for a square root, we cannot plug any negative values. So in this function, because this right here, let me highlight that for you. All right, this function right here, we can only plug in, make my pen here. Since we can only plug in positive values inside the square root, all x values have to be greater than or equal to 0 because you can plug in 0 into there, but that's what we have. Same thing can be said over on this other side. All right, same thing. So x has to be greater than or equal to 0. Now, because of this, what's the domain of this function? Well, we can look at these two values. Um, Whenever you do operations of functions, perform out the operation of adding, subtracting, whatnot, you always look at the original function and see then the second function if anything changes, and it doesn't. So our domain is all x values greater than or equal to 0 because it goes off of this part of the domain. Well, hopefully that made sense. We're going to do a couple more. Let's try the same thing. We're going to take now g of x plus g of x. So g of x is right here. We're going to add those two together. So we're going to have f. All right. Let's just show you something we're going to do. All right. Since we're adding g of x plus g of x, we can actually rewrite this as we have 2 g of x's. That's what I'm going to do. Which then would just be 2 times the quantity of g of x. G of x is this function. So it'd be 5x to the 1/3 plus 4x to the 1/2. We're then going to distribute this 2 through, so we'll have 10 x to the 1/3, and then we'll have 8x to the 1/2. And that, my friends, is our solution. Once again, let's find our domain. What is the domain? Well, once again, we see that we have x to the 1/2 power, which is a square root. This one, any values can plug in here. So our domain are all x values greater than or equal to 0. All right, let's continue on. We have 2 more right here. We're going to take now g of x minus f of x. Okay, g of x minus f of x. So let me put this in green. G of x, which we have, is 5x to the 1/3 power plus 4 x to the 1/2. Now, this would be very careful. We're going to subtract the function f of x. Now, the function f of x is represented by this expression. So we're going to subtract that entire expression. That's very, very important. We're going to take the opposite of that expression. So we have negative 3, opposite of negative 3x to the 1/3 plus 4x to the 1/2. So now, this is one of the key things, is we have to distribute through this negative. So what we actually have is 5x to the 1/3 plus 4x to the 1/2. Now distribute the negatives, so we have a positive 3x to the 1/3. And then we'll have the opposite of positive 4 is negative 4, so x to the 1/2. And now we combine our values. And that's it, 1/2. Excuse me. What happens here is we can add these together, so we get 8 of them. And we realize that this and this will cancel out, so we don't have any more. And that is our expression. Now, from here, we have to look at our original. Now, looking at this, we can see that right here, nothing, all right, anything can plug this function. However, looking at our original expression, we realize we still have x to the 1/2 power. So now, because of that, our domain is always set from the original function before it's simplified. So because of this, because x to the 1/2 isn't our original function, we know that we cannot plug in any negative values, all right, into there. So it's all going to be all x values greater than or equal to 0. So whenever you're looking at domain, we look at the original function, all right, and not necessarily the last output when we simplify. All right, well, let's check this out. We have g of x minus g of x. All right, this seems kind of redundant. Well, g of x minus g of x, unlike g of x plus g of x, g of x minus g of x, well, what is that going to be? Well, g of x minus g of x is going to just simply be 0. And that is our answer. That's our function. All right, what can we plug in there? Well, if you look at g of x, all right, this function, when you have it, will be still all values, all right, g of x, x values greater than or equal to 0. All right, that's what we can plug in, and we'll get an output of 0, and that's our domain. Because once again, we look at our original function, g of x minus g of x, and that's g of x has that, and that's what our answer is. All right, well, I hope this makes sense. Went through doing operation of functions, adding and subtracting functions, like right here, and also find the domain of the function, which is also very important, because domain is what we plug into the original function, which is very important. All right, so with that, hope this helps you out. Good luck and God bless in the rest of your problems.